really interesting stuff. Stoichiometry. Before I explain what that is, I just want you to know that I looked over your test, and there are 3 different categories of stoichiometry problems. And I'm going to have you write these categories. I'm going to have you write this first. 3 different types of problems on the test. And then here are your categories. You've got mole to mole, mass to mass, and volume of a gas at STP. Go ahead and copy that. Out of the 3, the easiest by far is volume of a gas at STP, and the reason why is you only have this one conversion factor, and it's a ratio, and what it says is at STP, whatever the gas is, it does not matter. It doesn't matter what the gas is. At STP conditions, you have 22.4 liters of that gas per mole. So it could be hydrogen, oxygen, nitrogen, fluorine, chlorine, doesn't matter. Okay, there's going to be 22.4 liters of that gas per 1 mole at STP conditions. Remember, this applies to gases only. Gases only. Okay. The next type that's easy is mole to mole. Mole to mole is easy. And then you've got mass to mass. It's more challenging, but not difficult. Okay, especially not if you compare it to a lot of really difficult subjects like calculus or statistics. This is not nearly as difficult as that. It's just a little bit more involved than either one of these. Okay, so before we get into any of that, let's just talk for a minute about making pizza. Okay, if I were to make pizza, this is my recipe for this is the recipe that I would use. Okay, and I know it's overly simplified, but this is the recipe I would use. I would use 2 cups of sauce, 3 cups of cheese, 1 crust yields 1 pizza. Go ahead and copy that recipe down, and then copy down the question. How many cups of cheese do I need if I have 2.5 cups of sauce? How many cups of cheese do I need if I have 2.5 cups of sauce? Well, it would be easy to tell you how many cups of cheese I needed if I only had 2 cups of sauce, but instead I've got 2.5 cups of sauce, right? So I got to figure out how many cups of cheese I need. I'm going to show you that right now. Okay, here's my answer, and you guys can just copy it down below your question. Okay, I just wanted to write this out to show you. If I had 2.5 cups of sauce, I would treat that as my given. 2.5 cups of sauce. These are my units, guys. I'd put that over 1, and then I'd multiply it by my ratio of sauce to cheese. Okay, so I'm converting from sauce to cups of cheese. And on the bottom I'd put cups of sauce. Okay, and I'd look back at my ratio here. I'd look back at my ratio and I would see that I have, for every 2 cups of sauce, I got 3 cups of cheese. So for every 2 cups of sauce, I got 3 cups of cheese, and that's my ratio of cheese to sauce. I can cancel out my units. That leaves me in the units of cups of cheese. And I can do my math. When I do my math, I say 2.5 times 3 over 2. Okay? That gives me 3.75 cups of cheese is what I need. 3.75 cups of cheese. Now if I were to use this analogy here and apply it to something like a chemical formula, we can think of a chemical formula as a recipe. We can think of it as a recipe to make a certain product. In this case, we're not going to make delicious pizza, but we're going to make delicious ammonia. Okay, so we've got nitrogen plus hydrogen yields ammonia. And that's our recipe. After we balance our equation, that's our recipe for ammonia. And we can ask the same type of questions. We can say, I have 2 moles of nitrogen. How many moles of hydrogen do I need? And this is a mole-to-mole problem. Okay, this is a mole-to-mole. This is example 1, mole-to-mole. mole to mole. Okay, I have 2 moles of nitrogen. How many moles of hydrogen do I need? Well, you attack this problem the same way that we just did with our pizza problem. Okay, and what we do is we say, you write out your given, 2 moles of nitrogen of N2 over 1. Then you're converting from moles of N2 to moles of hydrogen. So you just write moles of hydrogen up top, H2. You're going to cancel out moles of N2, so you write it down at the bottom. So now what you do is you look at your ratio. Just like cheese and sauce, you look at your ratio of nitrogen to hydrogen. And you see that for every 1 mole of nitrogen, there are 3 moles of hydrogen. Okay, there's 3 moles of hydrogen used. You can cancel out your units, like so. And you see that all you have to do is multiply 2 times 3. So in this case, your answer is very easy. It's going to be 6 moles of H2 is what you're going to need. Okay, that's example 1, mole to mole. I'll let you copy that. Okay, go ahead and copy this equation down again because we're going to use it for a new problem. Copy our recipe down for ammonia, and this is going to be example 2, mole to mole. Please write this underneath example 1. Don't try to reuse the same equation. It's going to get too complicated. It'll get too convoluted. Okay? Unfortunately, most of the word problems that you're going to get are not going to be that straightforward in terms of their language. They'll write it in a scientific type of language, so it'll sound more like this. How many moles of nitrogen are needed to completely react with 7.2 moles of hydrogen? Now think about what they're saying. Needed to completely react. Nitrogen and hydrogen react together, and if we have 7.2 moles of hydrogen, what they're asking you to say, what they're really asking you is, how many moles of this stuff are needed to completely mix with this amount of hydrogen to form this? To completely mix. So there's going to be nothing left over here. Okay? So we start again with our given. Our given is 7.2 moles of hydrogen. Okay, so let's go ahead and do that. What they're really asking you is the same thing that they're asking. They're asking you the same thing. How many moles do I need of nitrogen? Okay, to react with this amount of hydrogen. So let's go ahead and write out our given. Our given 7.2 moles of hydrogen. Over 1. And now, oops, we're going from moles of hydrogen. They're asking how many moles of nitrogen? Moles of N2 are needed. Okay, so to get to moles of N2, we've got to cancel out our moles of H2. We've got to cancel out our moles of H2. We do that by putting H2 on the bottom. Now we look at our relationship between H2, which is 3, and moles of N2, which is 1. Okay? So you've got a 1 to 3 relationship. Go ahead and copy that down. I can cancel out my units. In this case, it's moles of H2. And I can do my math. 7.2 times 1 over 3. 2.4 is my answer. Okay, 2.4 is my answer. Let me put that right there. There it is. So 2.4, and what is my units? Moles of N2. Moles of N2. I'm going to go ahead and stop the video and do part 2 on mass to mass stoichiometry.